so if I take a look at this graph number 4 here. Okay, I'm just going to shift this over. My work here. Okay. I need to find rate of change. Rate of change rate of change is the change in y over the change in x. How many of you guys understand that that is our formula? All right. So this is page 286. This is number 4. All right. So for us to find the change in y over the change in x, I just need 2 points. So I'm going to go to my graph here. I'm looking at my graph for where my line crosses grid lines. Everyone's eyes are on the board, please. I'm looking on this graph to see where my red line crosses grid lines. Because if they cross grid lines, I know exactly where that point is. So, how many of you guys see that right here, my red line crosses at this grid line? How many of you guys see that? So here's 1 point. Somebody go up and show me, where would another point be? Where does our line cross grid lines? Chris, go ahead. Go point to where you think there is another point. Absolutely. Here's another point right there. So there are my 2 points. How many of you guys see those 2 points? All I need to do is figure out what is the vertical change between those 2 points, what is the horizontal change between those 2 points. So somebody tell me, what is my vertical change if I start at this bottom one and I've got to go up and over? I can't go diagonal. Think about being on a road. I can only drive up or down, or I can only drive left or right. So how many am I going up? Serena, 2. So my rate of change for this is going to be 2 over, here's my 2. All right, how many am I going to the right? Remember, up is positive, down is negative. To the right is positive, to the left is negative. So how many did I go to the right? Matthew? 3. So my rate of change is going to be 2 pounds. Yep, pounds over 3 hours. So there is my rate of change. If I was to do this division, all right, this is going to end up being 0.6 repeating pounds per hour. And that's what I would expect to see. I think they did 2/3 pounds per hour, which is the same thing as 0.6. Questions on this? Okay, so let's take a look at number 5. I'm going to zoom in here. Now when you're graphing these, when you're drawing a graph, always just find 2 points on the graph and graph those 2 points and draw a line through it. So somebody go up there and point to 2 distinct points where our line crosses a grid line. Jacob, go ahead. What 2 points do you have where our red line crosses grid lines, where two of our grid lines cross together? Right here? And then where? Absolutely. There are my 2 points. So somebody tell me, I'm just going to do this right here on my book. My R of C is equal to my change in y over my change in x. So someone tell me, whether you start at your bottom point and go up and over to your top, or you start at your top point and go down and over to your bottom. Someone tell me, what is my change in my y? Let's say I start at that left point. What's my change in my y? Everyone's eyes are on the board so you understand how to do this. Part of what you do, you have to figure out what you're counting by. So, what is my change in my y? Ashton? Am I going up or down? Starting from here, going this way, and then over. I'm going down. So this is going to be a negative 500. And then I'm going to the right, correct, Ashton? So I'm going down, and then I'm going to the right. So how far did I go to the right? Did I go 2 places or 3? 3, and we're counting, what am I counting by? So what is that going to be? 30. So I have negative 500 over 30. So now I'm just going to do that division. So I end up with 500 divided by 30, and I end up with 16.6 repeating. They did 16 and 2/3 feet per second, because my numerator information was feet, my denominator information is seconds. And if you did that as 16 and 2/3, that's fine with me. But I'm good with that as a decimal as well. Since we're talking about a skydiver, and he's going down, that negative means that he's descending. He's going down in the sky, 16.6 feet per second. That's what that means. How many of you guys does this help a lot more too with these graphs? Okay. Now that I've done that, are there any other ones from this homework that you guys want to talk about before we move on with this section? Are there any other ones that you guys want to talk about? Isabella? 27? Okay, so let's take a look at number 27. Said, find the rate of change. All right, and they were telling us that we have a baby is 18 inches long at birth. So we say that they said the baby is 18 inches long at birth, and 27 inches at 10 months. What information are we measuring here? What information are we talking about here? Nick? What is the inches measuring? So the length of the baby. What else is being measured here? Sam? The months, or the age of the baby. How many of you guys agree, and this is in months, and this is in inches, how many of you guys agree that this is what we're measuring? Or what information have they given us? What information have they told us? Serena? When? So here's one set of information. What else have they told us? Excellent. So, for us to find our rate of change is equal to my change in y over my change in x. So what do I need to figure out with these two pieces of information? What do I need to know about length of the baby and the age of the baby? What do I have to determine with those? First, to do this problem. Don't I need to know which is x and which is y? How many of you guys agree that I need to know which of those is x and which is y? Okay. Your x information is always your dependent information. Or independent. Your x information is always your independent information. Your y information is always your dependent information. So I need to figure out which of these depends on which. Does the length of a person, of a baby, depend on how old they are? Or does how old the baby is depend on how long they are? Do you go in and measure a baby, see that it's 36 inches, and say, oh, they must be 2 months old? Or do you walk in and say, I have a 2-month-old baby, You measure them and you get your length. Which depends on which? Does your age depend on the length, or does your length depend on age? Chris? How many of you guys agree that your length depends on your age? Yeah, the older you get, the longer you get. So if my length depends on my age, so length depends on age, that means that my length is my y, my age is my x. So now that I have defined those variables, let's go back up here and figure out, here are my 2 points. All right, well, let's figure out. My length is my y, my age is my x. My length is my y, my age is my x. How many of you guys see that? Yes, you guys see that? So I can come up with a table of values here. I can write age and I can write length. So at birth, how old are you, Colin? You're 0. So at 0 months, the baby is 18 inches. What's the other set of data they gave me? Sam, what's the other set of data they gave me? What is the other set of data they gave me? We know at birth, the baby was 18 inches. Excellent. So I have 10 months, 27 inches. Now I can find my rate of change. My change in y over my change in x. All right, so I have 10 minus 0, which is 10. I have 27 minus 18, which is going to give me 9. Did I do that right? Right? Okay, so my rate of change is going to be 9 inches over 10 months. But I don't care about how many inches in 10 months. I want to know how many inches in 1 month. So this is going to be 0.9 inches per month, is what that means. So to find your rate of change, you need 2 points. Whether they give you 2 points on a graph, they give you 2 data points like they do here, you need 2 points so you can find your rate of change. Raise your hand if you're cool with this stuff. This is just the beginning of rates of change. So I know this is all new for you, but we're going to be doing more of this. All right, put this away, get your notes out. So today is 3-3. We are still in Chapter 6, Section 1. So 6.1 continued. All right, so this chapter is rate of change and slope. Okay, so let's review for a second where we've been. Rate of change. All right, this is your vertical change divided by your horizontal change. All right, that's also your dependent info change divided by your independent info change. We also write that as change in y over change in x. Okay. So those are all the formulas, those are all the formulas for rate of change. All right, rate of change we use rate of change when we have actual info, have actual data. So we have rate of change when we have actual data. Just don't worry about the time. For example, in our the length and age of a baby, we came up with our rate of change of 9 inches in 10 months. So we use rate of change when we actually have data. All right, but we always want to change that into a unit rate. So we want to change that into a unit rate. All right, so do the division. So this ended up being 0.9 inches per month. So rate of change is when we have actual data. Now, even when we get into story problems, I'll still use the next phrase, all right? We don't see rate of change, that phrase, a ton. We see the next term more likely being used in linear equations, but they mean the same thing. All right, so what I want to introduce to you is this idea of slope. All right, don't freak out. It is literally the same thing as rate of change. All right, so another name for rate of change is slope. So another name for rate of change is slope. All right, so we're going to be talking more about slope today. Again, this is exactly the same thing as rate of change. Typically, when we deal with slope, there's not, in story problems you'll see data, but on some of these it's going to be it's just going to be coordinate points. All right, so whether we have rate of change, whether we use the phrase rate of change or slope, let's look at the formulas for it. Who needs to see what's up there? So I'm going to start using this phrase slope. Are you good, sweetie? Awesome. So let's talk about slope. And I'm going to put in parentheses underneath it rate of change, because they are the same thing. All right, it still measures the steepness of a line. So we're talking about a graph. It measures the steepness of a line. All right, the variable we use for slope is m. It's just a lowercase m. That's the variable that we use for slope. So when we start writing linear equations, we're going to use the letter m for slope. Yes? I don't know. It's a great question. I really have no idea why it's m and not s. Yep, I didn't come up with these, so it's just like why the constant rate of change in the direct variation. Why is it a k? Why is it not a c? Right, for constant? I really don't know. Sam. Shh. Maybe. Yes. Shh. Excuse me. It could be Latin. Yeah, I really don't know. It's somebody much smarter than me that decided to come up with that. I really have no idea. All right. So rate of change, or slope as we're now going to be referring to it, is an m for its variable. All right. So let's look at our formulas. They're not different than the formulas for rate of change. So slope, it's your vertical change over your horizontal change. All right. This is when we have a graph. Another name for vertical change is rise. Another name for horizontal change is run. You're going to hear that a lot. So on a graph, our slope is our rise over our run. All right, it's still change in y over change in x, like it's still all of that, but now with slope, when you have a graph, I will refer a lot to your rise over your run instead of vertical change and horizontal change. All right, when we talk about our rise, up is positive, down is negative. When we talk about our run, to the right is positive, to the left is negative. We ran into that last night on our graphs. All right, so what I want to do is I'm going to give you a graph, and you're going to find the slope of the graph, and then we're going to talk about it, mix it up. If I don't give you a graph, if I just give you 2 points, how do you find slope? All right, so let's talk about finding slope from a graph. You guys need your rulers. You guys need your rulers out for the rest of this chapter. So as soon as you get out, as soon as you get here, if you grab your calculators, grab them, then grab a ruler. All right, so here's my example. Let's draw this graph. If you like colors, use colors. That's fine with me. Come on, no, you're not borrowing rulers from anybody. You guys should all have your own rulers. If you don't have a ruler, get one for tomorrow, please. Protractor, ruler, whatever. What? No. I expect you to have it in class all the time. I mean, there's no other class that uses rulers. So you gotta have it with your math stuff. All right, so you're drawing your axis on grid lines. All right, you're putting some increments on here. Always put increments on your graphs. Always have arrows on the ends of your axes. All right, so here's my line. Remember, always find 2 points on the line. So there is my line. So you want to always find 2 points on the line. Always need that because those are the points we're going to use to find slope. Yes? Just figure it out. I know you guys can see it. Don't be lazy. Just figure it out. Have the same points I have, please. All right. Remember, slope, always write the formula down. Slope on a graph is rise over run. It's your vertical change over your horizontal change. Now, this is what I have to see. I have to see the slope work. All right. So, if I start with this bottom one, how many am I going up or down? If I start at this left point, how many am I going up or down to get to my right point? Ava? So I'm going up 2. If you want to do arrows, that's fine with me. If you just want to do these dotted lines, and then I'm going to, how many am I going right? Peter? 5. So I'm just going to kind of, if you want to do this dotted line, that's fine with me as well. 5. All right, that is slope work is required. That's doing your subtraction. All right, that's your slope work. All right, so if I go back over here, I have a rise of positive 2. I have a run of 5. There is my slope. All right, and when we don't have specific data, we are leaving it as a fraction, as an improper fraction or a regular fraction. All right, so when slope is not actual information, leave as fraction or improper fraction. So my slope is 2/5, and I want to make sure that that's simplified. Yes? You would turn it into a unit rate, like the rate of change. Yep, so if it's actual info, you're going to do the division and turn it into a rate of change. Yes, Nick? Okay, so do I have any units on these? Is this like feet or inches or hours or minutes or anything? Okay, so there's no units on this. All right, so I guess when it comes to info, I guess I mean units. Like there's no feet or inches or anything. That number of people, they're just regular, they're just numbers with no information on them. No units on them. Does that make sense? Yeah. That's what I'm talking about. Do you know what I mean? Okay, so that's what I mean by no info. Okay, let's do another one. So I'm going to give you this graph, and I want you to find the slope. So draw your coordinate plane. Again, if you want to use a different color to show slope, that's fine with me. That slope work. I know you can't see what I'm drawing, but you will eventually. Alright, so there is my line. If you notice, I have not shown you specific points. You're finding where that line crosses grid lines. So find 2 points on that graph that you can use to draw that line. So look on here, look and see where our line crosses grid lines exactly. And use those as your 2 points to draw your line. And those will also be the 2 points that you're using to find your slope. So what 2 points do you see distinctly that our line crosses grid lines? Ashton? -1 and 3? Yeah, 4 and 1. There's another one there. So you're looking to see where your line crosses grid lines. So my slope is rise over run. You're always writing that down. So if I start with my left point, what's my rise? If I start with this left point, I want to go to my right point. What's my rise? Jacob? Yep, I'm going down 2, so there's my -2. And then what? So I'm going to this way 5. So my slope is -2 over 5. Visually, what's the difference between the 2 graphs I just did? Visually, what's the difference between this one and this one? Colin? Absolutely. And this one goes up from right to left, right? Or from left to right, right? What do you notice about the sign of this slope, of the line that goes up from left to right? What do you notice about the sign of this slope? Jack, I need you paying attention. Colin said that this first one, it went up from left to right, where the second one went down from left to right. Well, when it goes up from left to right, what is the sign of my slope? Blythe? Positive. I have a positive 2/5. What is the sign of my slope when it's going down from left to right? Ava? That's not a coincidence. That's exactly what it's going to be. All right, so when we have slope, if our slope is going up of our line, our slope is positive. When our line is going down from left to right, our slope is negative. Hi. That better be. Yeah. Oh gosh, I'm sorry. No, you're letting me know. Yes, thank you. Yeah, thank you. I'm sorry. Okay, so slope on a graph, rise over run, you need 2 points. Well, what happens if I don't give you a graph? Let's say that if I give 2 points, I want you to find slope. So if you are given 2 points, just 2 random points, how do I find slope? All right, this is my formula. Slope is going to be y2 minus y1 over x2 minus x1. This formula is doing that rise and that run on your graph. So instead of graphing it and finding rise and run, we can just go ahead and use the points and use this formula. Let's figure out what the heck I'm talking about. All right, so let's find the slope of the one we just did. So let's say that I want to find the slope of the line that goes through, and I'm just going to do the one that we just did, negative 1, 3, and 4, 1. We already know what this slope is because we just found it on the graph. But let's see and make sure how we can do it if we were just given those 2 points. Okay, what you're going to do is you're simply going to label. So I want you to label 1 point, x1, y1, and the other x2, y2. So I'm going to label one of my points x1, y1, the other one x2, y2. It doesn't matter which is which. So I'm going to label 1 point x1, y1. So let's call that first point my x1, y1. And I'm going to label the other one x2, y2. And now I'm going to use the formula, the slope formula. All right, so let's just do that next to it. My slope equals y2 minus y1 over x2 minus x1. So I've labeled my 2 points x1, y1 and x2, y2. That helps guide me and make sure I'm doing the right subtraction. All right, what is my y2? Jacob? 1. What is my y1? Ava? 3. So I have 1 minus 3 in my numerator. What is my x2? Victoria? 4. What is my x1? Jacob? Negative 1. So 4 minus a negative 1. Can you guys see why I label those points x1, y1, x2, y2? That helps me focus on how I can use the formula and which numbers go where. Now you do this subtraction. So I'm going to do adding the opposite on both of these. What is 1 plus a negative 3? Colin? Negative 2. Colin, what's 4 plus 1? 5. There's my slope of negative 2 over 5. Yes. Yeah, but you're not going to be given a graph of all of them. Yes, you could graph it, but don't spend the time graphing. Yes. Yeah, so if they just say, so this is what you're going to see is something like this. Everyone's eyes up here. you're going to see something like this. Find the slope of the line that runs through these 2 points. Instead of graphing that, you're going to use this formula. If you're given this, find the slope of each line, you're going to use rise over run. Does that make sense to you guys? So these are the 2 situations you're going to have. Are you guys cool? Awesome. You guys can go.